Hello, and welcome to another test oil live stream. This one is entitled Understanding Particle Counts. In today's presentation, I'm going to go through a little bit of the content that we cover in our comprehensive training to explain how to understand particle counts. It's probably one of the most frequently asked questions I get with regards to interpreting oil analysis results is, what do these numbers mean? Particle counts are very difficult to understand unless you're familiar with the way they get reported and coded. So I'd like to show you a few excerpts. I'll start with an excerpt we have here from our lubricant storage and handling section. In this section, we go through 5 different steps of storage and handling, and the first step above all is, of course, taking delivery of that oil. One of the things we point out about new oil is that new oil is not clean oil. And this is sometimes perplexing to people because they wonder, why is it not clean? Or what do you mean it's not clean enough? And one of the key statistics that I give out there is that new oil is an ISO code of approximately 2019-16, give or take an ISO code. And then I go on to explain how that is typically about 8 to 32 times dirtier than what your OEMs expect for cleanliness. And this gets very confusing for people for a couple of reasons. One is that why isn't it clean enough? And two, what do those numbers even mean? So in this live stream, I like to explain what those numbers mean. So to understand what 2019-16 are equating to, we have to understand how we came up with those numbers. So first and foremost, I'd like to explain how do we even do a particle count. So by its very name, a particle count is simply that. It is a count of the number of particles. But what we must take into consideration is it's a count of the number of particles contained within 1 milliliter of fluid. That's how the results are standardized. So 1 milliliter is not a very large volume, and when people wonder how big is a milliliter, the answer is it's a cubic centimeter. Now then you're wondering how big is a cubic centimeter? It's approximately the volume of the tip of your pinky finger. It is not very much fluid at all. And when the particles are counted in this volume of fluid, they are reported in at least 3 categories. The 3 categories that we need to know about are the greater than 4, greater than 6, and greater than 14 micron categories. There are other larger particle sizes reported, but these 3 go into the ISO coding system. So what I want you to notice is that every one of those was greater than, meaning that any particle greater than 14 microns is also a particle that will be counted as being greater than 6 microns, and all of those particles will of course also be counted as being greater than 4 microns. So when you look at a typical particle count result, it should not be unexpected to see that the 4 micron value is the highest number, followed by the 6, and then of course the 14. And that's simply because this is what we would call a cumulative count, meaning that each one accumulates into the next category, if you will. So with the particle count, we report, as I said, the particle count, the actual number of particles in those 3 sizes per milliliter of fluid. But what is also reported is some type of code, and that code is in the format following the order of 4, 6, and 14 microns. But what most people are curious about is, how do we get these codes? So to help you with that, let me show you the ISO coding table. So this table that you're going to see here on the left is a list of all the ISO codes and the ranges of particle counts that they have for each code. The 2 tables on the right-hand side are 2 different examples, and I will go through the top example. I don't think I need to go through the bottom example. Now, to understand this ISO coding table, we must first understand the pattern of how it was created. And the pattern is best seen if we start the 5th row from the bottom where it says ISO code of 10. An ISO code of 10 represents any particle count between 5 and 10 particles. If you go up a row to ISO code 11, you will see that the particle count now changes to a particle count between 10 and 20 particles. And if you go up another one, you see an ISO code of 12 represents 20 to 40 particles. Most people are pretty quick to notice the pattern is the numbers are doubling. What not everyone also realizes, though, is that the range is also doubling. The variance between 5 and 10 particles is only 5. The range between 10 and 20 is 10. The range between 20 and 40 is 20. Right? The ranges are getting bigger and bigger and bigger the higher the codes go, not just the counts themselves. And this is important to see and understand when we get to our examples. So the first example, like I said, I'll go through this top one here, and you can see the bolded values for 4, 6, and 14 microns. You can see the particle counts immediately to the right. So when you look at the greater than 4 micron particle count, you will see that it's 151,773 particles per milliliter. If you look over at the ISO code table, you can see that there's a range that covers anything between 80 and 160,000, which is where 151,000 and change would fit. And that is ISO code 24. So in the far right-hand column of the table, we would write 24. If we go down to the next result, which is just over 30,000, that falls in a range between 20 and 40,000, which represents an ISO code of 22. So we would give that one the code 22. And the last one, just being over 3,000, falls between 2,500 and 5,000, which is an ISO code of 19, and that would get assigned the ISO code 19. So in the end, this entire particle count would be reported out as 24, 22, 19. And if you're following me so far, I think what we've done is we've taken one set of numbers, the actual particle count, that you had probably no hope of really understanding well, and we've converted them to a new set of ISO codes that you probably still don't understand. Because in all fairness, 24, 22, and 19 don't amount to anything. It's not measured in pounds or gallons or any sort of tangible measurement. It's just a code. It's just a number to represent some other range. So I think I can provide you with a different example to help you understand it a little bit more clearly. So let me show you a typical set of particle counts. I'll show you 3 samples worth of results. You will see that they are labeled first, second, and third sample. And if you look at the results as we go from the first to the second to the third sample, and I ask you, what do you think the results are doing? Most people are pretty quick to say the results are going up. But if I ask you, are they going up by just a little or up by a lot? That is trickier to come to a consensus on, because some people might look at the results and go, well, they're all kind of the same. Maybe they're all, it's not much of a change. It's a small increase. Other people might look at those numbers and go, well, they've almost doubled when you go from the first sample to the third sample. I think that's pretty significant. And they might say, no, those numbers are changing a lot. Well, that's where it gets confusing. So ISO codes are to actually help resolve that kind of conflict. And let me show you how. If I was to refer to the previous table with the ISO codes and now try and code these results, here's what I would get. The first number's 1,357. That falls within a range of 1,300 to 2,500, which is an ISO code of 18. So for this first number, I could write in the ISO code 18. The second number is 361. That falls between the range of 320 and 640 particles. That is an ISO code of 16. So for the second number, I would write in 16. And the last number, 42, falls between the range of 40 and 80, which is an ISO code of 13. So for the last number, I could write in 13. So in the end, when I've coded this set of results, I would come up with 18, 16, 13 as a way of representing the first sample's particle count. Now, if I took the time to go through the other two, you would quickly find that actually all 3 of them are 18, 16, 13. So this is the point. All 3 samples work out to be 18, 16, 13. So if I asked you, looking at the ISO codes only, what is the particle count doing? Now we would all come to a quick consensus and say, it's not changing. Right? It is a stable particle count. And that's kind of the point of ISO's coding system. It removes the resolution for us interpreting a few hundred or even a few thousand particles difference between samples. The point is they're all in the same ballpark. So they're all approximately the same cleanliness or dirtiness, whichever way you like to sort of envision that. But what you're still left with is a wondering about, is it a lot or is it a little? What is 18, 16, 13? I still can't tangibly picture that in my mind as either being clean enough or too dirty for suitable purpose. So one thing I can show you is a very old study done by Caterpillar, and they took a 55-gallon drum and they approximated that it would only take 1/2 of a teaspoon of debris to contaminate oil to a level of 18, 16, 13. So these 3 particle counts I've just shown you all have, per 55 gallons of oil, approximately 1/2 a teaspoon of particulate, debris, whatever it happens to be. Now, If we take this and we go all the way back to my new oil statement of being 2019-16, and we know that 2019-16 is 2 or 3 codes higher than 18-16-13 if you compare them to each other. Every time we go up a code, we know the particle count doubles. If we go up 2 codes, it goes up by 4 times because that's doubling and doubling again. So we know there's at least 4 times as many particulate in a 2019-16 as compared to an 18-16-13. So we could therefore say that there's at least 4 times 1/2 of a teaspoon of debris in a drum of new oil. So there's roughly the equivalent of 2 teaspoons of material or more in every drum of brand new oil. And this does not matter if it is in a quart container, a pail, a drum, a tote, or even delivered by bulk. It doesn't matter if it's contained in plastic containers or steel containers. I'm telling you that by and large, the average cleanliness for new oil is 2019-16, give or take an ISO code. So just to give it to you a slightly different way and put it into a new perspective perhaps for you, on the left here, I'm showing you a microscopic picture of an oil that is 2019-16 cleanliness. And on the right, I'm showing you an oil that is significantly dirtier. It is used engine oil. Now, if I told you used engine oil was dirty, I don't think I told you anything you didn't already know. What I'm giving you, though, is a mathematical way of quantifying how much dirtier is used engine oil compared to new fluid right out of the container. So looking at the ISO codes, you can see that used engine oil is a 23-22-19. Again, reiterating new oil is 2019-16. If you could do a one-to-one comparison between the ISO codes, you can see that the engine oil is 3 codes higher in every category. Well, being 3 codes higher is doubling, doubling, and doubling again. So it is 8 times dirtier, as you can see pictured at the bottom of the slide there. So that gives you a rough way of coming up with an equivalent for how much contamination did my engine oil pick up compared to when it was new. So here's the other perspective I want to give you. If I keep the picture on the left the same, but I change the picture on the right to being in-service hydraulic fluid, and I show you now it's actually substantially cleaner, this is a different perspective. It is approximately 4 codes lower, 4 codes cleaner. And again, every time you go down a code, you cut the number of particles in half and in half and in half and then in half one more time. So you have 1/32 as many particles in the hydraulic fluid as you have compared to the new oil. Or the other way of phrasing it is the new oil is 32 times dirtier than is required by the OEM for that hydraulic system before it's ever been put into use. So this is where we come up with that statement now, and hopefully you can see that, whereby we can say that new oil is approximately 8 to 32 times dirtier than is required by the OEMs for various systems. Because new oil contains a certain amount of particles in it to begin with, and some systems, like an engine, may operate dirtier, but many, many systems will operate cleaner than is expected of new oil systems. Now, when I made this first comment, I did say 2019-16 was the average cleanliness of new oil, and I said give or take a code. Why do I say give or take a code? Well, let me show you another little excerpt when we go through our lubricant analysis section and we go through all the different testing. When we go through all the different testing, one of the things I focus on towards the end of each of the tests is a precision and bias statement where I point out how accurate or inaccurate can a test be allowed within the standards. And the ASTM standard for optical particle counting provides us with this list of data here. So you'll see that I've reproduced the repeatability and the reproducibility statements for the 4, the 6, and the 14 micron particle counts. If you look at the 4 and the 14 micron particle counts reproducibilities, you will see they are over 100%, meaning there can be a 100% or more change in the values, and that is considered error within the method noise on the instrument. So that is allowable change in the data and still be construed as good enough, the same result, if you will. What that can represent, and this is what I've highlighted at the bottom there, that can represent up to an ISO code change of 2. So give or take 2 ISO codes is practically within the realm of possibility for just simply how accurate an optical particle counter happens to be. So I hope that's a bit enlightening to you, that you should expect give or take a code to be your kind of go-to statement as you read any particle count going forward. But one last thing I'd like to leave you with before we finish the presentation is not everyone works with the ISO cleanliness system, right? Particle counting is particle counting. It's a number of particles per milliliter of fluid. It's an easy way of counting. It's when we code them that people start to get a little bit more confused, and ISO is but one of the methods. There are 3 others. There's one from NAS, and there are 2 different ones from SAE. And the core difference between the ISO system and these systems is that ISO counts are required to be reported per milliliter, per 1 milliliter, whereas NAS and SAE are counted out per 100 milliliters. Now, my caution to you is you simply don't take an ISO count and multiply it by 100 and you'll suddenly have yourself an NAS or an SAE. The other difference is that both NAS and one of the versions of SAE use what we call a differential count rather than a cumulative count. So what that means is instead of particles being counted in one range, being counted again in another range, with a differential count, each range is its own range, and there is no overlap, there is no accumulation, if you will. So these ranges are different micron values than the ISO code system, so you can't even subtract one ISO particle count from another ISO particle counts range and expect to come up with the same results. So kind of long story short here, my point is, please don't use any of the online conversion tables or charts that people purport to say that such and such an ISO code is equivalent to such and such an NAS or an SAE value if you need an NAS or an SAE value to compare to your OEM documentation. If you require that it's reported differently, simply ask the lab. It really is a setting on the instrument that we have, and we can tell it to report it to us differently. The count is all done the same. The reporting is all done through software. It's no problem to change it over to SAE or to NAS. So I highly encourage you to make sure that you're matching a true count to your requirements rather than taking whatever count your lab gives you and trying to convert it to whatever necessary format you think you need. So with that, I hope you've enjoyed the presentation. I do thank you for watching, and I will leave the chat open here for about 30 seconds, see if there's any questions come in. If not, I will end the presentation. But again, thank you for watching.